Welcome back, all my good humans. I am going to go on a hiking adventure. My first trail is one that is going to go up a hill on a straight line. And then at the top of that hill, I am going to go on a diagonal level going up another hill. My next trail is one that is going to go horizontally. And at the end of that straight line, I'm going to take the third trail, which is going to go diagonally up the hill. Then I am going to go down diagonally down the hill, back to where I started. I'm going to take that concept right into graphing linear functions. Linear functions are usually in the form of y equals mx plus b. And so there are two things that you need when you are graphing a linear function. You need the slope and you need the y-intercept, or what we also call the b. Linear function is in the form of y equals mx plus b. And we need to know that in this format, the m is going to be a slope and the b is going to be your y-intercept. Meaning that at that point, that's where the graph is going to cross the y-axis. And in order to find the slope, we know that the slope is going to be a rise over the run. So this is what we call the slope-intercept form. Sometimes the equation is also given to you in the standard form. And the standard form is simply ax plus by equals c. And then you will have to change it into your slope-intercept form, meaning that you have to rewrite it so that you can identify the slope and also identify the b value. Now, from this slope-intercept form, there are two things that you need. As I stated before, you will need your slope and you will need your y-intercept. Say, for instance, I give you an equation such that it is like this. Y is equals to x plus 2. We know off the top, because we need it in the form of y equals mx plus b, your 2 is going to be, your 2 would be your b value, which is 0, 2. That's where it crosses the y-axis. And because you don't have a number in front of the x here, and I always tell you it is going to be an invisible 1. So then your slope is going to be 1. So the slope is 1. So in order to graph this, we are going to always start with your b, which is called your y-intercept. And this is what we are called the coordinate. So you must look along the y-axis, and this is going to be your y-axis. This will be your x-axis. Okay? And you will find this is 0, 0, which we call the origin. So you need to go up to 2, which is here. You put your point there. And your slope is 1, meaning that your slope is rise over your run. So it is 1 over 1. To go up 1 from the 2, up 1 over 1, that's your slope. Up 1 over 1, that's your slope. I always tell my students that they will need at least 3 points in order to graph any linear function. So I am going to connect my points now. And this is what we will have. It is connected in this format. And we will have our line going like this. So this is going to be y equal x plus 2. You notice here, it is a line that is going diagonally, meaning it is going up the hill because it is a positive slope. When it is a positive slope, it is going up the hill. The next example is y equals negative 2x. You might be saying to yourself, wow, where is the plus b? But in actuality, the plus b is simply right here. And it would be plus 0 in this case. that means that it crosses the y-axis at the origin, which is 0, 0. And so your slope here, this is going to be your slope, and 0, 0 is your coordinate for your y-intercept, or your b. So on the graph, you have your point here at the origin, and your slope is -2, which means that it's going to be -2 over 1. You are going to go down to 1, 2, and you are going to go 1 over. Or you could have gone up 2 this way and go to the left 1. Either direction is good. Now you have 3 points. You can go ahead and connect your points like this. And you will label it. This is going to be y equals -2x. You will notice that it is going down the hill, meaning that the slope is negative. That's what we have here. And it passes through the origin. That's why it's simply written as y equals -2x. We just throw in the plus 0. Another example is y equals -1 over 2x minus 3. Now once again, you have your slope here, which is -1 over 2. This is your slope. It is going to be a negative slope, and this is your b. And your b is going to be in the format of 0, -3. So let's find 0, -3. The -3 is right here, and your slope is -1 over 2, down 1 over 2, which is right here, down 1 over 2, or you could have gone up 1 to the left 2. Always, you must know either direction because you are graphing and you want to make sure that you know your stuff. Now we are going to connect all our points, and we will get our graph looking like this. And you can label this as y equals -1 over 2x minus 3. Okay? Now I want to show you another example. The next one is y equals x. You're saying to yourself, y equals x. How is that going to look? Remember now that we need this to be in the form of y equals mx plus b. Because we already have the x, we can rewrite it as y equals 1x plus 0, so that you can identify yourself how to graph this. This is going to go through the origin, which is right here. Your slope is 1 over 1. You are going to start at 0, 0. You are going to go up 1 over 1 to the right, or down 1 to the left 1. And you can also do another one, down 1 to the left 1. Now you are going to connect these points. And this is your y equals x. One thing I must emphasize to you is that when you are graphing your function, whether it's linear, whether it's an absolute value, or whether it is a quadratic, you must use arrows at the end. These two arrows are showing you or indicating you that the graph continues. So you must make sure that you have arrows at the end, and you are labeling your graph also. The next line that I want to graph for you is x equals -4. X equals -4. Hold up. Wait a minute. Hold up. Wait a minute. Let me put some flavor in it. Now you will notice that this is not in the form of y equals mx plus b. So because it is like this, we can tell you that you're not going to have a slope here. X equal a number is telling you that the slope is going to be undefined, meaning that the line is going to be a vertical line. And so because it's going to be a vertical line, I'm going to graph this for you. It is going to look something like this. So I am going to look along my x-axis and not my y-axis for -4. And I'm going to just simply go up or down to get some points, and then you are going to connect your points. So now your graph will look like this, and this is going to be x equals -4. It's going straight up the hill. It's like what I would say, Spider-Man literally cannot climb up the wall. Okay? The slope here is undefined. Now I'm going to show you another example. Let's graph y equals 7. This is not really in the form of y equals mx plus b. But in actuality, yes, it is. There is something that is missing, which is a 0 value, or a 0 has there's something that is missing from here. Your mx is missing. And because your mx is missing, you can rewrite this as y equal 0x plus 7. And because you now have 0x plus 7, your slope is 0. Okay? And when the slope is 0, I always tell my students, hey, it's like slide to the right, slide to the left. You're moving from one room to the next room, and so the slope is 0. So therefore, the line is going to be a horizontal line. So we are going to find that it crosses the y-axis at 7, and so that line is going to go horizontally. And this is what it's going to look like. So at 7, and you can put just 2 or 3 points there, and you can then draw your line. You would end up with this. Once again, add your arrows to indicate that the line continues or the graph continues. On this graph paper, you will notice that you have a variety of linear functions taking place. But I want to emphasize the y equals x. And the reason being is that if you notice, y equals x is telling you that the same value for y is the same value for x. So for instance, if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. If you come over onto the left, if x is -1, y is -1. If x is -2, y is -2. So you need to note that this is what the y equals x looks like. Okay? I am going to show you an example of a standard form equation that is going to be given to you, and you have to know how to graph it. So let's start with 6x plus 2y equal 8. So you have to change this standard form equation into slope-intercept form. I also have a video on that, and you can go back and watch that video, how to change from standard form into slope-intercept form. So the first thing you have to do here is that you have to get the y by itself. So you're going to minus 6x because it is a positive 6x, so you have to do the inverse, and whatever you do on one side, you have to do it on the other side. So this is going to cancel out. You are going to bring down the 2y equal -6x plus 8. You must always write your x term first before the monomial constant. And then you have to go another step because you have 2 that is multiplying onto the y, and you need to solve for y equals mx plus b, so you have to get rid of that 2. The inverse of multiply is divide, and you are going to divide everything by 2. So once you divide every term by 2, you will end up with y equals -3x plus 4. Now you will be able to identify your slope and your b from this. Your slope is -3, which is going to be simply -3 over 1, and your y-intercept is going to be the coordinate of 0, 4. So you're going to find 0, 4 on your graph right here, and the slope is -3, down 1, 2, 3 over 1 right here. You can go up 1, 2, 3 over to the left 1, and you have 3 points, and then you are going to connect these 3 points. And so this is what your graph is going to look like. It's passing through +4. It is a negative slope, and you must label -3x plus 4. One thing I must say to you also, when you're graphing, it is best that you come toward all the way to the end of the graph. So even though I stopped right there, it's best to continue with all of your graph to the end if you are graphing on that area. All right, so I know I fudged a little and I just made it smaller because I didn't want some of my lines to intersect too much, but you should practice into getting it towards the end of the grid line if you're using a small space. This is how you graph any equation that's given to you, whether in the slope-intercept form or in the standard form. Not all the time you will be given a linear equation in the slope-intercept form. You have to remember to change it. And also another thing to remember, not all the time you will have a y equal. It could be an x equal, and you have to know how to treat that one. One thing I always say, x equal is like going straight up the wall. Can you literally climb the wall? No. So you can go back and watch my video on slopes and learn more about the various types of slopes. Thank you for watching, and see you on the next side to come. Bye now. Cheers.